All right, today we're diving into something huge in the world of AI. It's called Kimi Linear, and honestly, it might just fix one of the most annoying problems that's been holding AI back for years. So, have you ever wondered this? Why is it that the more we try to make AI smarter, the slower it gets? It's this bizarre paradox, right? You feed it more data, it should get better, but it also just grinds to a halt. And we're not talking a little bit slow, we're talking almost unusable. This isn't some tiny bug, it's the central problem everyone's trying to crack.
Okay, so the villain in the story actually has a name. It's called quadratic complexity. Sounds fancy, but here's what it means. Deep inside these AI models, there's a part called the attention mechanism. Its job is to figure out context, how words relate to each other. The problem is, with the way things have been built, the more text you give it, the amount of work it has to do doesn't just go up, it explodes. We're talking exponentially.
Let me give you a picture of just how crazy this is. Imagine you tell an AI to read a 1,000-page book. Now, to understand the last page, it doesn't just remember what it read. No. It has to go back and compare page 1 to page 2, page 1 to page 3, all the way to page 1,000. And then it does it for page 2, comparing it to every other page. It's insane. The amount of work just blows up into this massive, tangled mess. That is quadratic complexity. So you can see how this explosion in workload created a huge headache for developers. It basically forced them into this really frustrating choice, what we call the speed versus power problem. For the longest time, you could have one or the other, but you could absolutely not have both. And here are the two terrible choices they were stuck with. On one hand, you've got full attention. This is that reread every single page method we just talked about. I mean, it's super powerful, super accurate, but it's also incredibly slow, like watching paint dry slow. On the other hand, you have linear attention. Think of this as the skim the book method. Yeah, it's way faster, but it misses a ton of important stuff, which makes the AI pretty unreliable. Not a great set of options, right?
And look, this wasn't a small problem. Even the team behind Kimi Linear says so in their paper. They point out that this linear attention thing, it just never really worked that well. It had, and I'm quoting here, limited expressivity, which is a technical way of saying it just wasn't very smart. It struggled to get things right, even with short, simple pieces of text.
So for years, the entire field was stuck. You could either have a genius AI that moved like a slug, or a super fast one with the memory of a goldfish. That was it. But that's all about to change. Enter Kimi Linear. And Kimi Linear is not just some small, incremental update. No, this is a totally new hybrid approach. It's designed from the ground up to just refuse to make that trade-off. The whole idea is to get the best of both worlds, the blazing speed of linear attention, but with the deep, powerful understanding of full attention. So how on earth did they pull this off? Well, the idea is actually kind of brilliant in its simplicity. They build the model in these little blocks of 4 layers. For 3 of those layers, they use a new, really fast linear method. But then, and this is the clever part, that 4th layer is a full-power, full attention layer. It acts like a manager, stepping in to look at the big picture and make sure nothing important was missed. It's this simple 3-to-1 rhythm that gets that perfect balance between speed and smarts. Okay, but for that 3-to-1 trick to actually work, those 3 fast layers had to be way better than the old linear attention we talked about. They couldn't be the skim the book version. So this led to a brand new invention, what we can call the KDA secret sauce. And this is the magic right here. It's called Kimi Delta Attention, or KDA for short. It's a totally new kind of linear attention, but it has this one killer feature, a fine-grained gating mechanism. The best way to think about it is like a super smart bouncer for the AI's memory. It stands at the door and decides, on a really detailed level, okay, you're important, you can stay. You're just noise, you can go. It gives the AI precise control over what to remember and what to forget. And you can see the results right here. That smart memory control means KDA is way more expressive, that word again. It means it can actually understand nuance and complex ideas, unlike the old linear methods. Plus, it's built to be super efficient, so it runs fast on existing hardware. And maybe most importantly, it's great at tasks where you need to remember an exact detail from way back on page 1. Okay, so this all sounds amazing in theory. The concept is great, but does it actually work in the real world? Let's look at the numbers and see if Kimi Linear is really faster and better. Well, the data speaks for itself. This chart shows a test called the ruler benchmark. It's basically a really tough exam for AIs to see how well they can handle super long, complicated texts. And look at that. Kimi Linear doesn't just do well, it blows the others out of the water. It gets the highest score, easily beating the older methods. It's not just keeping up, it's leading the pack. Okay, we've seen that it's smarter. But is it faster? Oh yeah. And this, right here, is the mic drop. When you give it a massive amount of text, we're talking 1 million tokens, that's like thousands of pages, Kimi Linear is a mind-blowing 6.3 times faster. I mean, that's not just a little better. That is a complete game changer. And that wasn't a fluke. Look at this table. This is the average score across a whole bunch of different long text tests. And what do you see? Yep, Kimi Linear is right there at the top again. It just consistently proves it's not only faster, but it's also just plain better across the board. So what's the secret to all that speed? It comes down to being incredibly efficient. There's something called the KV cache, which is basically the AI's short-term memory. Kimi Linear slashes the amount of memory it needs for this by up to 75%. That's a huge saving, and it's what lets the model handle these giant documents without even breaking a sweat. So let's just recap. It's faster, it's more efficient with its memory, and it's more accurate. This isn't just another small step forward, folks. We could be looking at the fundamental design for the entire next generation of AI. But what does this actually mean for us? Why is this such a big deal? Well, for one, it's a drop-in replacement, so developers can start using it pretty easily. But more excitingly, this could finally unlock AI agents that can understand massive amounts of information in real time. Imagine an AI that can read an entire company's codebase or digest an entire library of scientific research and actually understand it. This makes that million-token context a real thing you can use, not just a lab experiment. And you know what the best part is? The Kimi team didn't lock this away. They've open-sourced the core of this technology, the KDA module. That means any researcher, any developer, anywhere in the world can now take this and run with it. It's going to turbocharge innovation for everybody. So that leaves us with one last really big thought. For so long, the story of AI has been about compromise. You get power or you get speed. But now we have a way to get both, to be incredibly powerful and incredibly efficient. The old rules just don't apply anymore. The question is no longer, can the AI handle it? The question now is, what monumental challenges are we going to give it next?